Thank you very much, Doctor. Good afternoon, everybody. So I will start with my presentation with the natural water chemistry. Actually, just I am not here to just present the things. Just I want to share my experience that I have gained during my service in the Pollution Control Board. So because today we have to discuss the water quality and analysis. So first of all, I will start my presentation with the natural water chemistry. What is the chemistry behind this water quality? And after that, we will go for sampling and how we have to collect the samples. And then after that, analysis. So now I will start with my presentation. Water quality parameters. Mainly, if you have to identify, if you have to assess the water quality. अच्छा यहीं से करना है. Okay. Okay. Water quality parameters. So basically there are very few parameters, that is temperature, DO, pH, alkalinity, hardness, nitrates, phosphates. These are the parameters that are the basic parameters to assess the quality of water. So I will start with one by one. What is the importance of these parameters? So you see this temperature of the natural water that affects water density, gas solubility, chemical reaction rates, organism growth rates, conductivity, pH, dissolved oxygen. Dissolved oxygen, as you know, the oxygen dissolved in water. So as the temperature increases, this DO level decreases. Then how this temperature, what is the sources of increase in the temperature of the natural water? That is heated industrial effluent. If the heated industrial effluent goes to the natural water, so it heats up the temperature of the water. So and then second is the runoff from the pavements, and then deforestation. Dissolved oxygen. Dissolved oxygen is very important parameter. Dissolved oxygen is the basic parameter for assessing the quality of water. The DO level, if it decreases, it means the quality of water is not good for anything, and it should be between 7 to 8. Dissolved oxygen is the measurement of oxygen dissolved in water and available for fish and other aquatic life. Indicates health of an aquatic system, can range from 0 to 18 ppm. Most natural water system required 5 to 6 ppm to support a diverse population. So as you see in this picture, the good is above 5, and if it goes below 3 milligram, it is bad for the aquatic life. Next, here again, as I have already explained, effect of temperature on the dissolved oxygen. As the temperature increases, dissolved oxygen decreases. As you see in this graph, as the temperature goes on increasing, the DO levels goes on decreasing. So hence the temperature of any water is required to be controlled. Here again, the importance of the dissolved oxygen. Here you can see increase in organic waste, means if this water is contaminated due to the organic waste, then Here is the increase in algae and plant vegetation, and consequently it goes to decrease in DO level, which is harmful the organisms. Then another parameter that is a very important parameter is the pH. As you have all you might have heard about this pH. pH is the log of H ion concentration. So determines the solubility of phosphate, nitrates and heavy metals. If the pH of any this water decreases, means if pH of the water is acidic, then these phosphates, NO3 and chlorides, heavy metals, they dissolved in this water, and then the water becomes contaminated. So pH, to maintain the pH of any water in any water source is very important. It should be between 7 to 8. It should not go below 7 or above 8.5 or so. Here again you can see the this neutral pH is 7, and below is stronger, and then alkaline is above 7 is alkaline. It goes up to 14 pH. 7 to 14 is alkaline, and then below 7 it is acidic. Here again the same as I have already explained. This is the in this graph is also the given the importance of the pH. In the fresh water, the pH should range between 6.5 to, as you see in this plot, it should be between 6.5 to 8.5, and seawater pH is around 8 pH. Estuaries is 8.5, and these streams in the catchment with the alkaline rocks also contaminate this water quality, and because strong alkalis are discharged from these rocks, and in that case the pH goes as high as up to 11 or above that. So then this water becomes alkaline. So now we will see what are the factors that affect the pH. So one and foremost is the industrial effluent. Industrial effluent, if that enters into the water in any water body, river, or any natural water body, or any your drinking water source, so it affects the pH. First parameter that is being affected by the industrial effluent or any contamination from the domestic source, that is pH. So we have to maintain the pH between 6.5 to 8.5. Then another is the bacterial activity. Bacterial activity means sewage. If the sewage from the domestic effluent, it goes to the and enters the water, then the pH either it decreases or increases, depends on the source of the contamination. Then chemicals from the industrial effluent that I have already explained. So these are the factors that affect the pH. And the third parameter, the most important parameter of the assessing the water quality is the alkalinity. Alkalinity refers to the capability of water to neutralize acid. Alkalinity means alkaline water. So it is the capacity of the water to neutralize acid. So the alkalinity of any natural systems, it should be between 50 to 150 milligram per liter as CaCO3. And this alkalinity also acts as a carbonates and the buffering capacity of this resistance to pH, because buffering the if the alkalinity is between 50 to 150, then it acts as a buffer to the in the natural water. So to maintain this alkalinity between 50 to 150 is also important. Then there is hardness. Hardness is another parameter that is also important in terms of water quality. Hardness reflects dissolved carbonate minerals in the water. So if the dissolved minerals are high, then the hardness will be more. So high alkalinity also leads to high hardness. So if the alkalinity of any water is above 150, then we can think that we can then assess that this water will also be hard water. Then the two other parameters are NO3 nitrate and PO4 phosphate. NO3 is the naturally occurring nitrogen which is found in soil, and it also goes into this water and it also contaminates this water quality. And similarly, you can see PO4 phosphate is another parameter. Then you can see this N2 cycle. This you have already know. This is a cycle. The nitrogen N2, and it goes on circulating within the natural system, uh, because it is. You can see, as in this cycle, you can see organic nitrogens matter. After decomposition, it gives rise to ammonia. Ammonia is then, after oxidation, it gives to NO2, and then NO2 after oxidation, it gives to NO3. So again, goes into the chain, into the plant, and then animals, and then again come to the natural waters. So this is the NO2. So this is an N2 cycle, and mm, and from this cycle, because when we while we are working in the pollution control board, when we have to assess the contamination, that from where this contamination has occurred, then we goes to this nitrogen cycle, that because the contamination is in the form of NO2 or NO3 or ammonia, so we can see, we can assess the from where the contamination has arisen. This is again NO3, which I have already explained, phosphates. Then another parameter is turbidity. Turbidity is the suspended solids in the water, suspended solids that remains in water, that is known as TSS. Conductivity reflects the ionic strength of the water. If you measure the conductivity, then it is the ionic strength of the water. Then if the conductivity is more, then it means the water quality is contaminated. That water is contaminated. Now, next I will come to the sampling. मैम हेल्प करेंगे जरा, वो वाला कौन, which is that folder? So this was my presentation. Basically, I want to F5. Okay. Now the importance of the collection and preservation of the water and wastewater samples. Actually, before giving the sample to the laboratory, it is very important to collect the samples. How it is to be collected, and how it is to be preserved, how it is to be handled, how it goes to the laboratory. So, because this is important, because otherwise you are putting so many efforts. आप लेबोरेटरी में एनालिसिस हो रहा है, देयर आर मैन आवर्स, cost, equipment cost, ultimately you are giving the results. On those results, it depends on any corrective measures that you have to take. Corrective measures depends on this analysis on the samples which goes to the laboratory. So it is very important that we should know how to collect the sample. So I will just briefly explain that in the pollution control board, or as per the standard procedure, as per the standard protocol, what is the procedure to collect the sample, how it is to be collected, what are the precautions to be taken while collecting the samples. So main objectives of sampling. First of all, we should know the objectivity. What is the objectivity? Why you are collecting the sample? Whether you have to design STP, whether you have to design ETP, or whether you have to take any other corrective measures for what is the objectivity behind that sampling. And second is the source from where you are collecting the sample. What is the source? Whether it is a industrial effluent, or it is a domestic effluent, or any other contamination. So accordingly, you have to design the sampling protocol before going to the field for collecting the sample. And how much sample you have to collect, it also depends on the how many parameters you are required to analyze. You have to analyze 5 parameters. Accordingly, you will take 100 ml or 1 liter samples. If you have to analyze more parameters, then accordingly, then you have to collect more sample, and then accordingly you have to decide that I have to collect 1 liter, 2 liter, 5 liter of sample. General requirements. Number one is the meet the requirements of the sampling program. Your sampling should meet the requirements of the sampling program. Number two is the handle sample so that it does not deteriorate or become contaminated or compromised before it is analyzed. Compromised means it should go to the laboratory as such. It should be sealed in such a way. It should be preserved in such a way that it should go as such to the laboratory. So handling of the sample is very important. Third is the ensure sampling equipments are clean and quality assured before use. Before you are using those equipments, for example, you have collected a day before, you have collected another sample that was contaminated, and again without cleaning you go to the field and you collect the water sample, maybe from the drinking water source. So if you are collecting that sample without cleaning your equipment, again it will reflect in the analysis, and accordingly you will not get the accurate results. And accordingly, if you have to design any corrective measures, you have to design any corrective measures, for example ETP, STP, or anything for that purpose, it will not be purposeful for that purpose. So hence it is also important that your sampling equipment should be clean. Fourth is the use sample containers that are clean and free of contaminants, that I have already explained. Fifth is the fill sample containers with or without pre-rinsing with sample. Pre-rinsing means you have to rinse that container with the sample so that it is conditioned properly. Third is the composite samples can be obtained by collecting over a period of time, depth at many different sampling points. Make a record of every sample collected and identify every bottle. You have to indicate on the bottle from where you have collected the sample. Eighth is the label bottles and document sufficient information for sample identification. Ninth is the before collecting samples from distribution system, you have to flush these lines so that there may not be any contamination due to those pipes or the distribution systems. Documentation before once it reaches the laboratory person should know exactly from where these have been collected, who has collected, so that in case of any legal consequences, or you have to file this report to the court, so you have to document it properly. So these are the examples that I have given, and this is the format that you have to indicate on the sample sheet, which should accompany the sample to the laboratory. So one is the unique sample identification number. You have to put some number, some code on that sample. This is the first step. And the name of the sample collector, who has collected the sample, that his name should be there. Third is the date, time, at what time you have collected, whether it was collected in the morning, evening, afternoon. Exact location is very important. You have to identify from where you have collected the samples. And then the temperature, because you have to record some of the parameters in the field, pH, temperature, DO. You have to analyze it in the field, and it should be indicated on this sampling sheet. Weather conditions, whether it is a rainy season. If it is a rainy season, तो dilution हो गया, है ना? Accordingly, you have to indicate accordingly whether it was a rainy season or not. And water level, stream flow. In case of rivers or streams, again you have to indicate these parameters. So this is the sampling sheet which should accompany this sample which you have collected from the field. Then generally there are three types of samples that we collect from the field. One is the grab, another is composite, third is the integrated. Depends on the source of pollution. If there is only one source, single source, you go to that site, you collect the sample, you take 1 liter, 2 liter, 5 liter, 100 ml according to the parameters that you have to analyze. Immediately you collect the sample, seal it and send to the laboratory. But in case of composite sample, there, for example, in the morning contamination is different, after 1 hour contamination is different, after 2 hours the contamination is different. This is the contamination of that source is not uniform throughout the day. Then you have to collect the composite samples, because composite sampling is then becomes important. Otherwise you collect the grab sample, then it serves no purpose. So you have to collect the composite sample. Composite sample means you have to portion that sample. For example, you are collecting at one time 100 ml, another after half an hour again 100 ml, after half an hour again 100 ml. Then you composite it, you mix this sample and make it 1 liter or 2 liter according to your requirement. This is a composite sample. So this is also the protocol, sampling protocol. Once you go to the field, you should know whether you are collecting grab sample or composite sample. Third is the integrated sample. Integrated means there is a source. There are so many sources. There are so many sources in one river. There are stretch of the river. There are so many sources that are flowing into that river. So you have to collect all those samples. So how you will collect? This is integrated sampling, means simultaneously you are collecting 100 ml, 100 ml, 100 ml at one time. Mix it again after half an hour, again after half an hour. Then you make it composite. This is known as the integrated sample. Composite sample means of one source, same source, single source. Composite means after half an hour, you are collecting so many samples, making it composite. So this is a composite sampling. But grab sampling, you go there, collect sample, and you come back. This is the grab sampling. And then integrated sampling means so many sources. Simultaneously, you're collecting the samples, making it composite, and then in the evening, you're coming to the laboratory with one sample at different places. Again, in the laboratory, there is one sample. It's okay. So this is very important because sampling, actually I remained in the pollution control, but actually sampling is very important. One should know how to sample the sample, how to go to the field and from where you have to collect the sample. It all depends on the sampling. Analysis is the secondary part. Graph samples I have already explained. This is the definition that has given. This is composite sample definition. I will read it out. Graph samples are single samples collected at a specific spot at a site over a short period of time, typically seconds and minutes. You go there and collect the sample, come back. This is very easy. Graph sampling is very easy. Composite sample provides a more representative sampling of heterogeneous matrices in which the concentration of the analytes of interest may vary over short periods of time and or space. This is a composite sampling. This is again continuation of that composite sampling. Composite sampling also can also be undertaken by the automatic sampling systems. Yeah, please come. So next is the integrated samples. Mixture of grab samples collected from different points simultaneously, as I have already explained, or as nearly so as possible using discharge weight methods. These are the advantages, disadvantages. This is important. Chain of custody procedures. What are the procedures that is to be adopted in the laboratory or from the field to the laboratory to keep that sample intact in the same, it should not be compromised or as I have already explained. So first is you have to put the sample level including barcode. Now we have the online facilities also. You put a barcode on the sample. Second is the sampling seals. You have to seal the sample properly. Field logbook. You have to maintain a field logbook where you have to indicate all the parameters that from where it is collected, who has collected the sample, at what time it was collected, whether it is a graph sample, composite sample or integrated sample. And then the chain of custody record means इसका custody means this is important who has taken this sample to the laboratory after collected by somebody else. If it has been collected by the same person and same person is delivering it to the laboratory, it's okay. But if it is being transported by the other person, it has to be indicated, it has to be recorded with the proper signatures of that person. He should also be authorized by the concerned authority to handle these samples. Then sample analysis request sheet. From the field you have to submit a sample analysis request sheet. Sample analysis request sheet is basically you have to indicate the parameters, the how many parameters we have to analyze in the samples. For example, it is a sewage. If it is a sewage sample, then important parameters are BUD, pH, and conductance, oil and grease. These are the important parameters. In case it is a industrial effluent, so there are another parameters you have also to you have also to analyze the ions, heavy metals, phenols, or pesticides, hydrocarbons. So there are so many parameters according to the process of that industry you have to analyze, and accordingly your request sheet should indicate all these parameters. Then sample has to be delivered to the laboratory by that person. It should be received by the authorized person in the pollution control board. As per the Water Act, it has to be received by the board analyst duly authorized by the authority. And then is the receipt and logging of the samples, and you have to he has to receive, means board analyst or authorized person in the lab has to receive this sample. And then the board analyst and whosoever is the in charge or board analyst of the laboratory then assign the sample. He will distribute the sample for analysis in the laboratory, and then the sample which is left over after analysis, it has to be disposed of properly. ऐसा ना हो कि वो जो sample आपका contaminated sample, it goes to the water stream as such. It has to be treated. After treatment, it goes to the outlet of your drain. So these are the custody or handling procedures that we have to follow while we are just sending the sample to the laboratory. So you can understand from this how important is this sampling is. Sampling is very important before analysis. Analysis is the secondary part. Then again, sample container, what is the container, whether it is a glass container you have to choose or plastic container you have to choose. So you according to this your sampling protocol or sampling design, or before you are going to the field, it should be decided whether you are for what type of sample you are collecting and what type of parameters it has to be analyzed. Accordingly, you have to choose a glass container or a plastic container. Then there is a spot analysis. We have to go for a spot analysis. Some of the parameters are required to be analyzed on the spot. That is temperature, dissolved solids, dissolved gases. Temperature, of course, it is very important. Whether temperature it is within that range or not, you have to indicate in the while it goes to the laboratory. It should be in the sampling sheet. Second is the DO, dissolved oxygen. Dissolved oxygen has to be analyzed in the in the field. What is the oxygen dissolved in that water? That has to be analyzed in the field. And there are some of the parameters. Once your sample goes to the laboratory, how much time it should be, within which period it should be analyzed, it is also important. Some of the parameters that has to be analyzed immediately. As soon as the sample goes to the laboratory, immediately the sample has to put to analysis for these parameters, that is pH, conductivity, turbidity, alkalinity. These are the parameters that has to be analyzed immediately after the sample reaches the laboratory. VOCs, volatile organic compounds, it has to be sampled in a zero headspace is important for preservation of those parameters, because zero headspace, if it is without the zero headspace, then the volatile organisms being a volatile, it will be off from that sample. So these has to be preserved in the zero headspace. So there is some reactions in the water that is always there while you are taking the sample from the field. As it goes to the laboratory, in between there is a chain of reactions. So you have to preserve the sample in the field itself, so that that parameter does not change. So certain cations are subject to loss by adsorption or ion exchange with the walls of the glass container. These includes aluminum, cadmium, chromium, copper, iron, lead, manganese, silver and zinc. These are best collected in a separate clean bottle. You have to take a separate bottle for these parameters and acidify this sample with HNO3 nitric acid to pH below 2 to minimize precipitation and adsorption on the container walls, because in the acid these heavy metals or these metal will dissolve automatically. It will not be absorbed on the container of the wall. While you are collecting, if you want to analyze the sample from these parameters, you have to put the sample for you have to acidify that sample to pH below 2. Similarly, hardness is the another parameter. So hardness is again can be preserved by adding HNO3 to pH below 2. Biological activity means bacteriological activity in the water, because there is, if there is sample is you have collected a sample domestic effluent from the field, there are the bacteria in that sample. Bacterial activity goes on, and you have to preserve that sample, and it should be preserved below 4 degree. You have to refrigerate that sample immediately as soon as it reaches the laboratory. Similarly, for CN, cyanide, as you know, cyanide is the highly toxic parameter. It's a very toxic. You already know NaCN or KCN. KCN is highly toxic. If you have collected some sample from the field, from the industry that is discharging KCN or cyanide in the form of NaCN or KCN, so you have to preserve that sample. Otherwise, cyanide will also the chlorine, if the chlorine is present in that sample, it will oxidize that CN. So you have to preserve that sample. You have to raise the pH to above 8 or 10 or more than 11. So it by NOH, sodium hydroxide, you have to add in the field and then refrigerate in the laboratory, and then you put that sample to analysis. General these consideration for analysis, once it reaches the laboratory, what are the general considerations? Start microbiological examination of water samples as soon as possible after collection. Immediately microbiological examination uh, should be done, because otherwise after some time there will be no bacteria in that sample. If the sample is contaminated with bacteria, if you are analyzing that sample after 1 day or 2 days, then you will not find any bacteria present in that sample. So you have to analyze immediately if you have collected in the field the bacteriological sample. Eye samples preferably at less than 10 degree during transport, if can't be analyzed within 1 hour. If analyze samples on the day of receipt whenever possible, for the bacteriological parameter or the BOD or the biological samples. In, as soon as the sample reaches the laboratory, at least on the same day, it should be put for analysis. Do not exceed 30 hours holding time from collection to analysis for bacterial bacterial contamination. Do not exceed 8-hour holding time for heterophic plate count method. if the analysis to be done by heterotrophic plate count method. Madam, next.
कौन सी खुलनी
Yeah, water and color. Now we will come for the analysis part. Method and applications for analysis. We have collected the sample, we have preserved the sample, we have handled the samples, the sample reached the laboratory, and now that sample has to be analyzed according to the sample sheet that has been sent from the field to the laboratory. So what are the water quality analysis? What is the basic parameters? One is the physical factors including suspended matter and dissolved substances. Second is the chemical factors including concentration of ions and pollutants. Third is the biological factors including presence of organisms, plankton, macroinvertebrates, fish, nutrients, etc. Physical factors. TSS is the total suspended solids. Total suspended solids can be measured by taking the amount of solid separated from the water sample. Means you have to filter that sample. You have to take a filter. You have to take a filter, then filter that sample, filter paper, and filter that sample, and you take the initial weight and final weight. Accordingly, you collect the suspended solid. Dissolved solid is also very important. It is determined by the evaporation. You have to take the initial weight of the China dish and then final weight. Accordingly, you have to analyze the TDS. Then this turbidity is again another parameter. This also shows the presence of TSS. This is analyzed by an instrument, and by using an instrument, nephelometer. Values are NTU. In NTU, you can indicate these values. Then another in the analysis, another very important aspect is the use of spectrophotometer or colorimeter. Spectrophotometer, most of the ions or these phosphate, NO3 or chloride or these some of the heavy metals also, most of the heavy metals I will say, these are analyzed by using this spectrophotometer. Some of the spectrophotometer are the UVVS spectrophotometers, and another for the heavy metals there is a AS, atomic absorption spectrophotometer, that is used for the estimation of heavy metals. So you collect the sample, you acidify that sample, and after acidify, because all the heavy metals are digested in the acid, and after acidification of that sample, digestion of that sample, these samples are put for analysis for the heavy metals by the AS, means atomic absorption spectrophotometer. Means basic concept is the spectroscopy. By the use of spectroscopy, you can identify these ions, cations, as well as heavy metals. And these organic compounds, mostly these pesticides and hydrocarbons, these are analyzed by the use of the GC, that is the gas chromatograph. Then here is this the pH. What is the pH? pH is a measure of the increase of hydrogen ions in water. This is the pH, how it is measured. This is, you can see in this diagram, the electrodes. These are the pH electrodes or the pH. This is the handy pH meter that is being used. If you are going to the field, you can go with this handy pH meter and you can analyze the pH in the field itself. Even in the laboratory, even in the laboratory, same procedure is there. You can analyze the samples in the laboratory also. Dissolved oxygen is, again, it can be measured by using the DO meter, by the Winkler method, Winkler titration method, which is the standard procedure for the analysis of the DO, because DO is very important parameter in whole of the analysis. Once you have analyzed the DO and conductivity, these are two parameters. If you know the DO and conductivity, you can know how much how much this water is contaminated. So these two parameters are very, very important before you are analyzing any other parameters. If the DO is very less, so means your oxygen in the wastewater is no there. Means your your water or your natural body is contaminated with the organic matter. This organic matter has consumed whole of the oxygen from that water. So your DO depletion, this is the name, that is specific name that is in the environmental field which is used, that is the DO depletion. Means if the DO is depleted in any natural water body, means that there is a contamination due to the organic matter. Organic matter means maybe due to sewage, maybe due to solid waste, maybe due to industrial waste, maybe due to any other human activity. So DO is very important. Once the DO is maintained, your water is, it's okay for any purpose you want to use that water. Similarly for the BOD, BOD is the biochemical oxygen demand. Biochemical oxygen demand in the environmental field is very important. So if you have to design any sewage treatment plant or effluent treatment plant from the treatment of the contaminated water, so you must know the BOD, biochemical oxygen. Biochemical oxygen demand means oxygen requirement of that wastewater. If the wastewater is contaminated with organic matter, if the BOD will be more than the this means that water is highly polluted and DO will be very less. So DO and BOD are inversely proportional to each other. These are the two parameters that is basic parameters for designing any treatment plant, designing any effluent treatment or sewage treatment plant. The BOD is some of the it is the main parameter that you must know what is the BOD. And DO is the basic parameter even for the analysis of the BOD. Even for the effluent treatment plant, if you are going to the, there is an aeration process. You are engineering students. You might have seen there is an aeration. Aeration is what? This is the dissolved oxygen. You are giving the oxygen to that water because that water is contaminated with the organic matter or any other contamination. So you're giving the oxygen. Oxygen means to for the bacteria, because this is a bacteriological activity. Basically this is activated sludge process. If it is if you have seen the effluent treatment plant or the sewage treatment plant, there is an aeration process. Aeration means you are giving the oxygen to that water, and there is a bacterial activity going into that. That is, organic matter is degraded and it is converted to the harmless yes, decomposition of that water, oxidization of that water, oxidation is being taken place. So then this DO is also used for the analysis while you are analyzing the BOD. You are putting the sample for analysis. Initial DO, before putting that sample for 5 days in the incubator, you are measuring initial DO. Then after 5 days, you are measuring final DO. So what is the difference? It gives the your indication of the organic biochemical oxygen demand, means oxygen demand of that wastewater. So okay, this is very important. So all these parameters are being analyzed by using the spectrophotometer. These are the NO3, phosphate, sulfur, iron. These are all the parameters. These are the parameters that is being uh, analyzed by using the spectrophotometer. Conductivity, again, one more parameter that I want to discuss with you, that is the conductivity. If you know the conductivity of any water, if you go to the field, you analyze in the field conductance is very high. How you will assess whether it is organic effluent is there or inorganic contamination is there? Conductivity mainly indicates the inorganic part, means this is the ionic strength of that water. If the conductivity is more, means there is the contamination by the ions or cations. Ions may be heavy metals, maybe sodium, maybe potassium, maybe chloride, or maybe anything else. Then it, at least you know in the field there is a inorganic type of contamination, and if you have to identify the source, immediately you can identify the source. That what is the source? It is not the domestic effluent. Okay. And one thing is more, if the conductivity is high, it's not always that the BOD will be high. You say, you come to me, that, sir, we have conductivity is very high, it means this water is very contaminated, but BOD is not. BOD is below the standard. So it is not contaminated. Why the conductivity is high? Means the conductivity mainly represent the inorganic part, means ions, and but the organic part is being represented by the BOD, biological part. Biological part is by the BOD. COD is another parameter, that is the chemical oxygen demand. Chemical oxygen demand other than organic. Yes, both. So it will be purely represented by the COD, not by the BOD. So sometimes BOD is sometimes if you design your ETP or STP on the basis of the BOD only, so sometime it will be very wrong. It will give you in the wrong path. You're going to the wrong path. You have to identify all the parameters. Then you have to see the uh, there's a correlation of these parameters, and after that only then you can say whether it is inorganic, organic, and what is the contamination, how much is contaminated, how you have to design the part, whether you have to go for the precipitation or you have to go for the aeration. Accordingly you have to design your STP. Second is, if there is an inorganic as well as a organic, so you have to remove inorganic part before your this effluent goes for the aeration. Means you have to precipitate it out before it goes to the, otherwise it will kill your bacteria in the aeration tank. Okay. So these four parameters are very important. If once you understood these parameters, so you can design any effluent treatment plant or sewage treatment plant with yourself. It's not be any problem. This is again a conductivity meter. You can see this is a conductivity meter of fresh water. It is being measured in the microsiemens, and it will go to sea water, because the sea water conductivity is very high, then it is to be represented by millisiemens. If you are interested further for the analysis of the DO and BOD, then I can show you one or two slides more. If you are really, it's okay.